We are going to take a little bit of time right now to summarize and wrap up the rotations introduction that you worked on last week. So first of all, a couple of reminders about rotation. So rotation is spinning a shape. So if we wanted to give that an informal definition, it's spinning. And we said that you have to spin it around an anchor point. So in the rotations activity you were spinning around the origin. So that's where you put your pin down to literally spin your paper and make your shape spin. So we have to have a fixed point that we're spinning our shape around. And I showed you in the intro video as well that if you move that point and spin the shape around a different point, it actually changes where the shape lands. So that anchor point is important. It does have a name. It's called the center of rotation, which logically makes sense if you think about it. It's the middle or what we're rotating around. So you have to have that anchor point or center of rotation. You also need another piece of information if you're rotating, and that's how far you're rotating. So in the intro activity, you did 3 different distances. You did a 90 degree, a 180 degree, and a 270 degree. So if you're spinning your shape, you need to know when to stop spinning. So when you're rotating, you have to give what's called the angle of rotation. And that basically is how far you're spinning. And it's measured in degrees since you're going around in a circle. So the angle of rotation. And that is basically your how far. And again, measured in degrees. So rotation is a spin. You spin around a center of rotation, and you have to give the angle of rotation, which is how far you're spinning. Now, similar to a translation and a reflection, which are the other 2 types of transformations that we've already talked about, when you spin a shape, spinning that shape around a point, the shape is not going to get magically larger or smaller while you're spinning it. It's the same shape. You're just changing what we call the orientation or the direction the shape is spinning. So similar to a translation and a reflection, a rotation will always create an image that is congruent or the same size to the pre-image. So those are the basic things that you are using when you're rotating your shape. Now what I want to do is summarize some of those things you were noticing that happen to the numbers when you rotated. We're going to turn your observations. You guys made a lot of good observations, and there are quite a few of you that were spot on with your observations. And I noticed 1 or 2 of you even giving me some pieces of the rules. So you're definitely on the right track with your observations. We're going to take those and we're going to pull those together into some rules. So the first observation you did was 90 degree clockwise, and you'll see this giant blank parenthesis thing here. I want to point something out. We were going clockwise, which is the same direction as the clock hands. So we were spinning this way and kind of landing right here, if you think of it. Now, I could also spin the opposite way, opposite direction, and land in that same point. But if I'm going to spin the opposite direction, instead of just going to the next quadrant over, I'm going to have to pass through 3 quadrants if I go the opposite direction. So it's kind of like 3 90-degree turns. So a 90-degree turn one direction, you can get to the other direction by turning 270 degrees, or kind of 3 90-degree turns the opposite direction. So a 90-degree clockwise turn is the same as a 270-degree counterclockwise. Remember, counterclockwise means the opposite direction clock hands turn. So counterclockwise. So that is an important thing to add into your notes, because in the intro we were spinning clockwise. You can spin counterclockwise, and every counterclockwise rotation has a matching clockwise rotation that goes with it. So most of you noticed 2 things that happened with your coordinates when we did that 90 degrees clockwise notation. First of all, you noticed that the x and the y coordinates switch places. The other thing that you noticed was that the new y coordinate is its opposite, or negative. And that actually has to do with just what quadrant you're landing in. So when you're doing these 90-degree rotations, rather than getting hung up on what's supposed to be positive and what's supposed to be negative, if you can just remember, oops, sorry, I didn't mean to do that. If you can just remember this part, the X and the Y coordinates switch places. The positives and the negatives are going to be whatever the correct positives and negatives are for the quadrant you landed in. So when you were doing your intro activity, your shape started in quadrant 1. And everything in quadrant 1 is positive, which is why your numbers are positive. Your shape landed in quadrant 2. Well, we know everything in quadrant 2 has a positive X and a negative Y, which is why your new Y coordinate ended up being the opposite, or ended up being negative, because you were in quadrant 4, is where you landed. You were in quadrant 4, and everything in quadrant 4 has a positive X and a negative Y. That's why I said, if you can remember this piece right here, that the X and the Y are switching places, then what's going on with the positives and the negatives is really just going to be whatever it's supposed to be for the quadrant you're landing in. So if we wanted to turn that into a rule, we can say, take your original coordinates. The X and the Y trade places, so the Y is now the X, and the X is now the Y. And the Y coordinate, the new Y, so the second number used to be your X, so it's the second number, becomes opposite. So Y negative X would be your new coordinates. The second rotation you tried was a 180-degree rotation. So that one you might be thinking, no, wait a minute, this one doesn't say which direction you're going. 180 degrees is the one rotation that it doesn't matter which way you go. Because if 180 degrees is halfway around a circle, if I go halfway around a circle clockwise, I'm going to land in the exact same spot if I go halfway around the circle counterclockwise. So 180 degrees, it doesn't matter which way you spin, you're just basically going exactly opposite the circle. So on this one, the X and the Y coordinates don't trade places, but what they do, which most of you guys noticed, was that they are all opposites. So opposite has to do with the signs of the numbers. So we started over here in quadrant 1 in your intro. We ended over here in quadrant 3. Well, we know everything in quadrant 3 is negative, so that's why all the numbers were negative. But because we were just going straight across, nothing was trading places. It was the same shape, just on the opposite side of the graph. So the rule for that would be take whatever your coordinates are and just make them the opposite. And that's going to send them to the opposite side of the graph, which is 180 degrees around the circle. The last one that you did was a 270-degree clockwise rotation. And we were just talking about the fact that every clockwise rotation has a matching counterclockwise rotation. So if you go 270 degrees around the graph, that's passing through 3 quadrants. If I were to go the other direction, that would be the same as just going through 1 quadrant. So it would be the same as a 90-degree counterclockwise rotation. So if you're going counterclockwise, you would use this rule if you're going 90 degrees. So 90 degrees counterclockwise. So this one, because we're turning 90 degrees again, this is another one where the X and the Y coordinates, kind of like the first one we did where they're going to switch places. And again, if you don't want to get hung up with what's positive and what's negative, you can just focus on this fact that whenever you turn 90 degrees, your X and your Y are going to switch places. And the positives and the negatives really are just going to match whatever quadrant you landed in. So in the intro activity, everything started positive because we started in quadrant 1. And we ended over here in quadrant 2. Well, we knew everything in quadrant 2 is negative X, positive Y. So what ended up happening was the X and the Y switch places, and then the new X coordinate is opposite because all of the X coordinates in that quadrant are negative. So the new X coordinate is opposite. So the rule would look like this. So you take your 2 coordinates, and you apply the rule, and the X and the Y switch places. So Y is now X, X is now Y, and the new X coordinate, so what used to be the Y, what's now the first number, that number needs to be its opposite. So that is our rule. Now, the nice thing about rotation rules is if you can get your rotation rules managed for your basic, 90 degree and 180 degree rotations. So remember, 270 degrees is really a 90 degree rotation if you go the opposite way. You probably noticed when you were rotating your shapes, a lot of you were probably very reliant on your paper and actually tracing your shape and spinning your paper to see where it landed, because it's really tricky, especially 90 degree rotations, to visualize where the shape's going to land when you're first starting or when you're first learning how to rotate. So that's where knowing the rules is really nice, because it takes the guesswork out of where the shape's going to land. You can just use the rule and then take those points and put them on the graph and have your shape exactly in the same spot. So, couple of examples. So we have our triangle MAY, and we want to know where it's going to land after some rotations, so that if we wanted to, we could just take that and put it on the graph. So this is a 90 degree counterclockwise rotation. So we want to find that from our list of rules. So our 90 degree counterclockwise rotation is the same as 270 degrees clockwise. So that actually is going to be this last rule that we did right here. So that is the rule that we're going to want to apply to all of our coordinates. So we want to take our coordinates and we want to switch them. And then after we switch them, we want to make what is now the x coordinate be the opposite of what it was before. So I can go through and I could use that rule on each of the 3 coordinates and get the new coordinates without having to guess where they go on a graph. So M prime, if I switch the x and the y, then it's going to be -3, 2. But I have to make the new x coordinate, this first number, be the opposite. Since it already was negative on this one, making it its opposite is going to make it go positive. So M prime would be +3, 2. Now I'm going to do A. So I need to switch the x and the y. So 5, 4 turns into 4, 5. And I need to make what is now the first number its opposite. So it's going to turn into a -4, 5. And the last one, y prime, I need to switch the x and the y. So -1, 7 turns into 7, -1. And I need to make what is now the first number its opposite. So that would be the 7. So it's going to turn into a -7. So the coordinates of my triangle after I've rotated counterclockwise 90 degrees would be 3, 2, -4, 5, and -7, -1. The second one says, okay, now take the original triangle. No, there's no prime marks there. That means we're coming back up here to the original triangle. Take the original triangle and rotate it 180 degrees. I like the 180 degree rule. It's easy to remember because nothing changes places. All you have to do is just take everything and make it its opposite. So it's basically saying wherever you are on the graph, you're going directly across the graph. Well, directly across the graph is always going to be the opposite of any location that you were starting at. So we're going to use this rule that says, okay, whatever you are, make you the opposite of what you were before, but don't switch anything. So that means our M double prime, if it was 2, -3, it's now -2, +3. So you can see I just switched the signs. A double prime was 5, 4. So now it's -5, -4. And Y double prime was -1, 7. So if I take both of those and reverse them, that's going to make it +1, -7. So if you were to graph both of those triangles, they would be directly opposite each other on the graph. So that's kind of a little bit about how you can use your rules. So if you know your rules and what rule to use and what that rule is telling you to actually do to the numbers, then it's going to give you some tools to be able to rotate shapes much more quickly, because now you're not going to have to trace the shape on a piece of paper and spin it like you were in the intro. And also accurately, so that you're not sitting there trying to visually guess where the shape goes on the graph. The rules tell you exactly where it's supposed to go. So that is what you were noticing about rotations summarized. So you're going to take these ideas now that we've summarized them, and you're going to try a practice assignment with rotations. So when you're ready for that, you're going to go ahead and work on that assignment. And I will tell you, when you're working on the assignment, at this point, you should not need tracing paper. So if you're trying to rotate a shape and you're not sure where it goes on your assignment, use your rules to help you. And that's exactly why we just summarized.